So we are looking at covalent bonding this morning. The other day, we looked at ionic stroke, electrovalent. So with examples, we concluded. So this morning, we are getting introduced to covalent bonding. I'll allow you.
This color.
I can't see you.
Those who have issues with vision or audio, you first leave, then join afresh. First leave the room. Amina, what is your problem?
Yes, teacher, I wanted to ask, last time I wanted to ask, like, how you, like, if they told us to show the formation of aluminium oxide.
So you want to, okay, then you mute. So let's continue. So she wants us to look at the formation of aluminium oxide. From aluminium oxide, yes, I mean, what's the problem?
We cannot see you.
You first leave the room, come back. Leave it again. Because you cannot see. First leave.
Those who can see, first go the other side and take it.
Those who cannot see you or hear, first leave and enter afresh.
Right. So let's continue. Somebody was talking about aluminium oxide, briefly. Then shall go to covalence. Aluminium oxide. Aluminium has atomic number 13. This electron configuration is 2 to 8 3. Oxygen has atomic number 8. Electron configuration
I said,
2 to 6. This is an animetal. Gabe, Slim, can you mute your microphones? We don't want to deal with a very stubborn class. Asto, mute your microphone. Angel, mute your microphone or else I remove you. Within 5 seconds, I will remove you from the room. Mugabe, if you don't mute, I'm going to remove you. Shifa, I'm going to remove you. So let us continue. We are saying those who cannot hear, sign out. Aluminium oxide, oxygen 2 to 8. So if that is the state of affairs, so electronic structure for aluminium. When you look at this, means aluminium can give out a maximum of how many electrons? 3. Aluminium can give. We say the metals do give out. Non-metals gain. So aluminium can give out 3 electrons. Oxygen can receive 2 electrons. So we will give out the electron 2. So if I've got a structure of aluminium, this is the nucleus, that's the outer energy level, inner energy level, next energy level, the outer energy level. This aluminium has 2 electrons inside. It has and it has 3 electrons to the outermost energy level. Now, oxygen can so far, if this is oxygen, with the 2 electrons followed by 6 electrons. So this is 1, 2, 3, 4, 5, and 6. So what will happen? It means that this electron is going to this oxygen is comfortable, but aluminium has an extra electron here. An extra electron. Now this is right here. Aluminium is satisfied. Oxygen is okay. This oxygen is not okay. Follow this. I'll need another aluminium ion atom. with also X out, and X out. So these ones remaining 8 in nature. So what happens? These electrons transfer that point. This atom also becomes now you people, you are becoming so indisciplined, you are going to be removed. All those whose microphones are on, you are going to be deleted right now. For the sake of others to learn. You know what to do, but you don't want to do it. So what happens now? This is E. There is one E here. There is another E here. There is E here. There is E here to give us the 6. These are the 8 inside. So what happens? This electron comes here. This electron comes here. So what does it mean? We need 2 of this. Total of 1, 2, 3, 4, 5, 6 electrons to be given out. So shall it be 3 oxygens, each take the 2 electrons to form an ionic bumper. So drawing this is going to take a lot of time. You can see drawing about 10 diagrams is not. What do we do at the end of it all? The cheapest is to say, I have the aluminium atom followed by 8 electrons outside, followed by 3 electrons outside. Instead of drawing another one, I'll put the 2 here so that there are 2 of them. I'll have saved the burden for this is oxygen. I am saying oxygen is the nucleus, the outer energy level, and it has how many electrons? 6 of them. So this is 1, 2, 3, 4, 5, and 6. But how many are they? They are 3. So when these come together, there is going to be electron what? Transfer. So you can show, at least you can show that one of them. You can even show another one and write electron transfer. So what do we obtain? About the nucleus of our energy. And how many are they? They are 2. So I put it. Here, insert this bracket. Each is losing. What follows next? These ones are 3 of them. I put that bracket. I insert the nucleus, inner energy level, outer energy level. These are 2. There is here, there is E, this is 2 minus. Bring this one 10 times. So this is the summary of this. You have seen that these ones are 2. These ones are 3. Therefore, in the aluminium, so degree. So what do I do? Put a charge.
Okay.
I the mic is on hazard.
Again, draw this one. You see, there are two of them. All of them bonded to 3 of these ones. So the nucleus, this is E, this is XE, and these ones. So from there, a moment. I drew another one like this. This. These are 1, 2, 3. 3 of this. This is 1, 2. 2 of these ones. And these are 3, but I am repeating all of them. So sometimes you have to use integers to save on the time and save on the space. This the electrons. So each is losing 3 electrons. So 3 plus. Each is gaining the 2 electrons from here. You can see each is gaining ionic bonding. Right. Let me ask. Sorry. Yes. Babire, what is your question? Babire, your hand is up. Yes.
I haven't
Your question cannot be picked because there is a lot of breakages. What you do is you send a message. Send a message, a reply. Your message,
and
your question.
The first
I'll continue. So that today we look at covalence. So today we are the following must be noted. In the covalent bonding, it's going to involve sharing electrons. The other time we say the transfer. One gives, another one accepts. Today, what are we looking at? Sharing electrons. So what are we sharing? Electrons in the outermost energy level, and what happens is going to be between sharing the electrons. Let me continue. These electrons are contributed by both atoms, and these atoms must be non-metals. What was electrovalent bonding? Transfer of electrons from metals to non-metals. Transfer of presence from boys to girls. The boys become positive, the girls become negative. Like it is stated in physics, the unlike poles do what? Attract. So that friendship is what we are calling ionic because it's between a male and a female. Between the North Pole and the South. And these things will happen at a later stage, chemistry outside the classroom. Now, this morning we are changing the question and saying, no, instead of transfer, what are we looking at? Sharing. We share. But as we share, everybody must what? Contribute. And who are those who are sharing? Must be only and only what? Nanometers. So what are the nanometers? There are 4 nanometers. It will take 6 and will take place in group 7. Group 8 will not get involved. Why? For them, they are full, inert, they do not react. The other day it was between metals and the nanometals. Today it is only non-metals and by sharing electrons. So these are girls alone. But whatever they are sharing, everybody does what? Contributes. So boys are out of the system now. So in the studio, I have 3 girls. So if they are going to share break, then break, each one has to contribute. Each one has to contribute. You can contribute 1 bottle of soda, you can contribute 2, you can contribute 3, you can contribute 10, but the issue is everybody has something to contribute before sharing begins to take place. I have seen this happen at school where girls go and buy their break and put the break in a common place. Everybody puts, this one brings hard knocks, I don't know how you call them. This one brings popcorn, the other one brings zombies full of oil, the other one brings chapati, the other one brings whatever you put, the other one comes with the guavas, this one brings popcorn. Put in a common place and begin to eat from the same source. You are sharing, you are all girls, you are all contributing. So whoever has not contributed is kicked out. Pexing is not allowed. Testing what you have not contributed is not allowed. So what have you captured? 3 things: sharing electrons. Hello, Katusime, those are bad manners. Sharing of electrons contributed by atoms, and it is among the non-metals. Period. So what is a covalent bond? You can think of a definition by yourself. So how do you define a covalent bond? As an individual, think of a definition. I'll come back and tell you. Those in the studio, what is a covalent bond? Remember, a bond is some force of attraction that binds. So what is a covalent bond? It's a force of attraction. That keeps nanometals, that binds nanometals together as a result of sharing electrons contributed by the participating atoms. We shall find out in chemistry that these atoms that are sharing electrons, these atoms can be similar. If not similar, the atoms can be different. They can be similar, they can be different. Important things to note. Yes, now, yes, please. Yeah, sharing electrons between which type of atoms? Non-metallic atoms. I want sharing non-metals, both contribute. Whichever form you want to say, that is it. I'll ask you later. Shalom, your microphone, you mute it. We are hearing your conversation with your chicken and so on. I don't know. So that's what it means. The atoms can be similar. The atoms can be different. Take note of that. In the studio right now before me, I have two atoms that are similar. In the studio right now, I have three ladies. Two ladies are similar. And therefore, it could be between one of the ladies who are similar to a different one. I don't want to mention the names. Give me an example of similar atoms. Similar atoms could be hydrogen and hydrogen. In the chemistry, what's the formula for hydrogen? The formula for hydrogen is H what? H2. Hydrogen is a typical element, by the way. Those found in group 1. It is a gas. It gives out electrons and so on. It shares an example of a similar molecule. As we continue to talk more, it could be between oxygen and oxygen. What's the formula for oxygen? O2.
That's like it.
So I'm going to remove. So those who are discussing other things, I am removing them. I've removed Wendy. Fahima, you are the one who is next to be removed. So it could be between nitrogen and nitrogen. What's the formula for nitrogen? N2. These are similar atoms. It could be between chlorine and chlorine. Formula for chlorine is Cl2. These are similar atoms. If the atoms are different, give me an example. It could be carbon what? Dioxide. Carbon and oxygen are different atoms. It could be water, hydrogen and oxygen. It could be other gases, as we shall see. Therefore, covalence is between similar or different atoms. Now, types of covalent bonds. What have we captured? Sharing the electrons, contributed by participating atoms, and these atoms must be nonmetals. They originate from group 4, group 5, group 6, and group 7. These atoms can be similar. These atoms can be different. Examples of similar atoms are given. Examples of different atoms are given. And all of them are non-metallic in nature. So allow me advance on types of covalent bonds. Types. Number 1, there is what we call a single covalent. There is what we call double covalent. Double. And you know what double means. Roman 3. Think of one, and I'll tell you whether you mention whether it will be right or wrong. Think of one, 30 seconds. There is what we call triple. Double P, single P. Single P. Triple covalent bond. There is a fourth which is not very common. What do you think would it be? Quadruple. Where single means 1, double means 2, triple means 3, quadruple means 4. So what is a covalent bond? I want to remind you that an ionic bond, we use the what? A dot between the two ions. A covalent bond, we use a dash. So written as dashes. These are simple dashes. So what does it mean to have a single covalent bond? It means you have that one. What does it mean to have a double covalent bond? It means you have, as if you are saying, equal signs. What does it mean to be triple? You have 3 of those dashes. What does it mean to be 4? You have 4 of those dashes. In chemistry, this is not confusion, signifying bonds. So in e-learning, we say dashboard. This is not a dashboard. It's signifying covalent what? Bonds. So how many bonds are there? 4. Single, double, triple, and a quadruple. Common ones will be single and double. Rarely shall we meet triple. And on very, very extreme rare occasions, quadruple. Lessons are different from notes. Mariam, you don't unmute, you are off. So let us see, where do we have single covalent bonds? Simple logic will be, to get a single covalent bonds, it's going to be between group 7 elements. Group 7 versus group 7. So this one is shown between the group 7 elements alone. So when 2 group 7 elements come together, and we shall end up with the single covalent bonds. When group 6 elements, 2 group 6 elements come together, double bond. When 3 group 5 elements, 2 of them come together, triple. When group 4 come together, we might end up with a triple bond. So senior 1 girl versus the senior 1 girl, friendship, single covalent bond. A senior 2 versus a senior 2 girl, friendship, double. Senior 3 versus senior 3, triple. Senior 4 versus senior 4, quadruple. I'm not talking about boys because boys are not any metals. Boys are metals. So this is the issue for ladies alone. But is it a must that a senior 1 cannot bond with a senior 2? A senior 1 can bond with a senior 2. We shall see the bond may not be single. It may be single, it may not be single, depending on the balance. Right? So, I want to end this session by saying, when did you see a single bond? What does it mean to have a single bond? If you have captured this one, I want to add so that my work is continuous. So let me try to reduce so that I can write and complete. A single covalent bond is noted as that. A double covalent bond is noted as that. Triple is shown as that. Quadruple is shown as that. What does it mean to have a single covalent bond? So here we are looking at type, notation. How do we represent it? Number of electrons. Number of electrons shared. What did we say? Formed by sharing what? Electrons. So where you see a single covalent bond, what does it mean? So let us say electrons shared. The moment you see a single covalent bond, it means 2 electrons shared. 2 electrons shared. And what are we saying? Both atoms do what? Contribute. So what does it mean to you? Both atoms contribute. Now, 2 electrons being shared, what does it mean? Yeah, in the studio. Atoms in covalence share electrons, isn't it? And if we are to form a single covalent bond, it means 2 electrons are being shared. So what does it mean? How many electrons do each one contribute? Each one contributes 1 electron. You bring 1, I bring 1, they become 2, we share. So each atom contributes 1 electron. Each atom contributes 1 electron so that they become 2 to be shared. So what does it mean? It means that the left hand brings 1 piece of chalk, the right hand brings 1 piece of chalk. So what happens? We put these 2 pieces of chalk together to share between the left hand and the right what? Hand. But each one has contributed 1 piece of, and this is going to happen in group 7. So sharing is going to take place so that atoms have a total of 8 electrons in the outermost energy level. Sharing is going to take place such that each atom has how many electrons in the outermost energy level? 8. We shall see. Allow me push on, yes? Both of them. The force of sharing. When you share, it becomes, and the girlfriend, you share the same friendship between you and him when you are playing football on the compound in the field. Playing the football, you are friends, but the friendship is not the same as the other. So what is the friendship? Sharing brings in friendship. That friendship is what you are calling a covalent bond. Do you share with enemies? Why are you my friend? Okay, why are you his friend? Answer. Somebody is asking me a question, the student, I'm also asking back. These ones deleted them, they are now thinking of coming back. Is this one your relative? So why is he your friend? Sharing what? There could be smaller things. Holy, then they are peeping at Nabila, say, hey, that kind of thing. So it is not. Suppose it was your blood brother. The friendship cannot be of the same strength. Now this one brings dogs in the class. Clarissa, you have said to bring dogs in class. We are going to remove you. So what does it mean? Therefore, using your mathematics, think about this question. How many electrons should be shared in order to come up with a double bond? Therefore, if 2 electrons constitute a single covalent bond, how about a double covalent bond? It would mean that you need 4 electrons. Because the 2 forms 1. If there are 2 bonds, what will happen? 4 electrons. So what do you think? Here each atom contributes 2. Each atom, if there are 2, each contributes 2 electrons. You get it?
It occurs when 4 electrons are shared between 2 atoms that consist of 1.
When 4 electrons are shared between 2 atoms and each atom contributes 2 electrons. Those will be the marking points in writing an essay. How many electrons is each contributing? How many are being shared? So is it single? Is it double? Is it triple? So triple means 6 electrons shared. Each contributes 3. Quadruple means 8 electrons shared. Each contributes 4. Do you see group 7 elements? How many electrons are the outermost energy level? 7. So they need what? 1. To raise the number to 8. That's why each contributes 1. Group 6 have 6 electrons in the outermost energy level. They need how many? 2 electrons to raise the number to 8. That's why each gives legs 2 electrons to the friend. So they share 4 electrons in the middle. So when I come, I find the 4 chapatis. I will imagine the chapatis are yours or the chapatis are for the other friend. Because if I cover you, I will see your friend with 4 chapatis. I'll say the chapatis are for the bill. But when I cover the other person, I now see the other one with 4 chapatis. The chapatis are yours. Common table, common food for everybody. So this is the scenario. Right? Okay. So let me see, there are a few issues here and I'll respond. The information is those who are giving us one names that will become a problem, you're not going to be admitted. Write your correct names as they appear on our school list. So this is techno person, techno spark 4. This is Girian over Girian who, over Girian Muhumuza, over Girian in Sereko, where the male or female. Please identify yourself very well. You'll be admitted in the room. I have Nantaba. Your hand is up. I've asked you to unmute and ask your question.
I was asking, can you please make like single covalent in a diagram?
I'm going to show that in the diagram. Thank you, Answer Mozanina. She's saying, let us continue. And that's where I'm heading to. Thank you so much. I want to go to diagram. So, Munira, mute so that you're not removed. Mute your microphone. You have asked, can you mute? Wonderful lady. Nabila, this time Nabila from outside also wants to ask. Let me allow Nabila to ask, and we shall continue.
Teacher.
Yes, Nabila, ask.
Teacher, those are the only types of covalent bonding.
Yeah, there are the 4. We shall discuss one at a time until we finish all of them. For today, at least for one, atoms that are similar, we are going to go into that. Can you mute your microphone now, Nabila? Lower your hand and unmute. That is good. Hajara, ask your question.
Teacher, I was asking like single covalent bond, like is the electron configuration supposed to be 2 to 8 to 7?
We are going to see that in a diagram in my next discussion. That is okay. Ada, Lukwago, can you ask?
What I've not understood is like the electron structure, like it's 2. Like that's what I've not understood.
Of course, now you are saying, let's go to the next and we shall go. Mr. Baima, now these ones who have corrected the names, do you admit them? Okay. Okay. So now let's go and look at typical examples. I hope you have captured this summary. Notes sometimes can challenge, but with the discussion like this and the summaries, you can now follow the notes and understand them. Somebody is playing with the screen. I've missed this person. Hey, Nachibala, we are going to delete you. You joke around. Yes, please. In the studio, ask. Yes, you ask in the studio.
When 4 electrons are shared between 2 atoms, then in triple, are we supposed to say when 6 electrons are shared between 1 atom?
You cannot share between 1 atom. It must be 2 atoms, at least 2 or more. Now let us use similar atoms only. I want to give an example of a single, a double, triple, and covalent between the similar atoms only. Before we go to different. So covalence in similar atoms. Covalence in similar atoms. We are beginning with 1 single covalent bond. So listen carefully. Robina, you are liable of being removed. Mute your microphone. I don't know why you are muting. Christopher, why are you muting? And Christopher, you're not our student. Masawi. So single covalent bond. I want to think of 2 examples. Let me think of hydrogen and chlorine. These are typical examples to be used here. So what is the atomic number of hydrogen? 1. It is 1, belongs to group 1, but it's a typical non-metal. The way you have somebody who is looking like a boy, but this person is actually female. So when you group people, you can group this girl among the males because she's masculine. She can play football like a guy. She has been carrying the metals. She has the chest, but actually she's a female. So all her behaviors, in most cases, resemble the behaviors of males. So when you are talking about boys, you include her. But actually, and she puts on trousers, and actually she's a girl. So hydrogen takes 2 positions. It takes position 1 as a group 1 element, also takes position number 7 as a group 7 element. So hydrogen atomic number 1, that's the nucleus. How many electrons are found in hydrogen? Only 1 electron. What did octet rule tell us? The law say the first energy level is supposed to carry a maximum of 2. Now it has 1. Is it stable? No. That's why it has to look for somebody to share with. Fortunately, it's going to share with fellow hydrogen. So I am bringing another hydrogen here. I don't have colored chalk. I should have used the colored chalk to illustrate this. But for purposes of just learning, let me use now E. But all of them are standing for electrons. If I had a colored chalk, I'll use X here, which is a different color. Or you can use a pen, blue and red. Blue and a pencil. So when the two come together, what happens? Covalence is when you bring 2 things, 2 different things, this atom and this atom, you bring and put them together. So I'm going to join these 2. They touch one another using the outermost energy level electrons. In ionic bonding, Rahima, Nasozi, you stand a risk of being flushed out, mute. So in ionic bonding, they remain just close to one another. They didn't touch, but very close to one another. This time, these energy levels are touching. So when they touch, the best is I'll begin with the outer ones. They now touch one another. They can intersect in mathematics intersection, or they can just touch. So this is the nucleus. This is also the nucleus. This atom here, this is its electron. Now this one, this is its electron. So how many electrons are being shared by both? 2 electrons. This one came from this one, this electron came from this, and they are all sharing them. So if I cover this atom, what have you seen? That atom has how many electrons? 2. It is stable, isn't it? Supposing I cover this one, that atom also has how many electrons? 2 electrons. But raise the number to 2 by the idea that another person of its own kind has also contributed. So they don't belong to this one alone. They don't belong to this one. They belong to both of them together. And now they become what? Stable. That's why sometimes I say 2 lonely hearts. Or to complete the what? The phrase. So you get it. So what's the electronic configuration of this one? It is 1. The electronic configuration of this one is 1. What's the electronic configuration of each of them? This one now becomes 2. And for this one also becomes it's 2. But it's using an electron which is not its own electron. You get it? So stability acquired. So here I have H. Added to H, I am now getting H connected to H. This is a single covalent bond. Walda, I'll give you time to ask. For now, ask for now, first listen. Put your hand down. I'll give you a chance to ask. I'll allow you ask Walda later. And mute. Shifa, I'm going to flash you out for the second time. This one is Champire.
Yeah.
Can mute or else you go out. When you tell them to mute, they mute. So what is this? H connected to H, isn't it? So this is what we are calling hydrogen gas. If it was ionic, it should have been H dot H. It's not dot this time, it's dash. So what do we see? A single covalent bond. If I ask you to write the notes, what should you have said? Two atoms are coming together. Each is contributing one electron for sharing, full stop. Two electrons are what? Shared, and leads formation of a single covalent bond. Two atoms each contributes one electron for sharing. Since the two electrons are shared, a single covalent bond is formed. Assume when Roshan, you have risked going out. Roshan, I'm going to flush you out of the room. So this is what it means. Let me use the second example, chlorine. Second example, chlorine. Atomic number for chlorine, 17. Electronic configuration, 2 to 8 to 7. First energy level, 2 electrons. Second energy level, 7 electrons. 8 electrons. Third energy level. What about the third energy level? To remove this one. Third energy level, how many electrons? 7. So these are 2, followed by 8, followed by what? 7. 1, 2, 3, 4, 5, 6, 7. How many do I need to raise the number to 8? How many do I need to raise the number to 8? 1. Isn't it? So I'm going to put this one electron here. I add another chlorine. Those are 2. These are 8. And how many are these outside also? 7. E. I'm going to put the electron to be shared next to one another. You don't share when you are hiding. You bring, I must see it. So what are we going to form now? What did we agree? The two atoms touch one another, or they can intersect. They can intersect. It is allowed to intersect, so that you put the two electrons here. It is acceptable, and after that will be the best. They can intersect. So what is intersection in mathematics? Numbers, elements that intersect are found in both what? Both sets. So this is set chemistry, set mathematics, but in the chemistry. So what do we do? They either touch or intersect. And thereafter, I know the other energy levels. So let's begin with this one alone, with the X's. These are the two X's inside, followed by 8. That is 1, 2, 3, 4, 5, 6, 7. Are they over? The 7, are they over? Yes. Let's try the next. Let's try the next. This one. So let's begin. Inside there is E and there's E. What follows next? 8 is. This is EE, 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 and EE. What follows next? The 7 E's outside. These are the original 2 E's. These are the original 2 E's. These are the original 2 E's. And this is the E that has been brought in a common pool for sharing. So, electronic configuration of this atom alone was 2 to 7, 2 to 8 to 7. This is also 2 to 8 to 7. What's the electronic configuration of this atom alone? When I close this, what's the EC for this atom alone? 2 to 8 to 8, and 2 to 8 to 8. So the EC is now 2 to 8 to 8, 2 to 8 to 8. As a result of sharing. You get it? So what is it? Cl, single bond, Cl. Why single bond? Why is it a Cl, single bond Cl? 2 electrons have been shared. So what are the notes? The notes are 2 atoms of chlorine combined by sharing 2 electrons, each contributing 1 electron. So we end up with 2 atoms being held by a single covalent bond. These things happen in school. Don't tell us. I know. I've dealt with the students. I've interacted with you. I know a lot. During time for checking for books, what do you do? Now, others in the room are laughing. And some people are saying, some people say, oh yeah, teacher. Somebody say, oh yeah. What do you do when it's time for checking for books? Don't you give friends your book to bring for signing, for checking? And when you bring your friend's book to show that you have the books, what happens? The book now belongs to what? To you. But it's for the other person. So these things you practice them without knowing. How can one chemistry book belong to 3 girls? You do this number, do the other number. How come when you're submitting the holiday work, you brought holiday work that you had copied from one another? So whose work was it? Was it the act of sharing? So I look at it and oh, okay. Now who is this one? And I checked, by the way, I saw whose work? Mutesi's work was just similar to somebody who is in the studio right now. So whose work was it? It was an act of sharing, which is covalent in nature. So this one clarifies. People who are saying, now show using a diagram, I'll show you. So what do we see? 2 electrons shared, 2 electrons shared. Single covalent bond. Allow me look at double covalent bond. Have you seen that all of them are group 7, group 7, group 7, 1 electron? Yes, single dash.
Why can't we use the dash of the atom?
This one, you can't use a dash, they will be separated. You use a dash when you're writing symbols. And in the chemistry, when you see the atoms being connected with a dash, it means covalent sharing electrons. So we use a dash when you're writing the symbols, not diagrams. You get it? So let us look at double. I am through with the single. Single, what does it mean? 2 electrons being shared. Each atom contributes 1, mostly among a group 7. So double is mostly among a group 7, group what? 6. And the best example shall use is oxygen. So let us look at double. I want to finish all the 4 bonds, then I'll open a discussion. Double. What did we say double? 2 dashes. What does it mean? 4 electrons. Electrons done what? Shared. What does it mean? That each contributes how many? Each contributes 2 electrons. So let me look at oxygen. Oxygen O, atomic number 8, electronic configuration 2 to 6. Do you say I need 2 electrons? So oxygen versus oxygen. My dear friends, this is now oxygen atom. Electronic arrangement 2 followed by 6. So since I want 2 electrons, I must be ready to also give out how many? 2. So I'm going to put 2 electrons here. And I put 2 this way. How many electrons are from the outermost energy level of oxygen? They are 6. So another atom comes in. How many electrons inside? 2. Outside, how many? 6. So what are the 6? E. Let me put these 2 here because they want to be shared. And I put these ones here. What's the EC? 2 to 6. 2 to 6. So 2 to 6 and the 2 to 6. If they contribute and share, let me use also overlap this time. Intersection, other near touching. You are free to use any. So if I draw this as oxide, the first oxide, they either touch or we say they can what? Intersect. So it's not being seen. Let me use the intersection type also this time. So how many energy levels are those inside? 1. And therefore that is it. And this is the nucleus. That is it. And this is the nucleus. So let me show the X's alone. X alone. How many X's inside here? 2. How many X's outside? 6. But it will be in the intersection. Mirembe, put your hand down. I'll give you a chance to ask. So this is X. This is X. The contributed X's are here. So this is X and the X. Let me cross the EE diagram. So the EE diagram, these are the 2 E's. 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 If you don't want this one, then you do the one where they just do what? Touch. It's you to choose convenience. So at this point of touching, how many electrons are there? There are 4. 2 X's and the 2 E's. So how many electrons are being shared? I have 4 electrons being shared here. X, E. This atom contributed this X and this X. This atom has contributed this E and this E. Total 2 electrons have been contributed by each atom. And therefore, when you count, what is the EC of this atom alone? By closing the other one. So the EC for this atom alone is 2 to 8. And for this atom is also 2 to 8. Stability by sharing. So what is the formula of oxygen? The formula of oxygen is O dash O, which we comfortably write as O2 because we're not interested in showing the bonding. So what happens in oxygen? What happens to the 2 atoms? The 2 atoms are held by a double covalent bond. Let me hear the word double covalent bond. It means 4 electrons shared and each is contributing 2. That is for oxygen. Group 6. And we shall use for group 6, we use oxygen. Can I go to at least triple? So let me go to at least a triple covalent bond. Triple. How many electrons will be shared? 6. Each contributes 3. So what do? You put 3 electrons at the edge where they're going to touch one another. So typical example, and this is going to happen in group 5. And the best example in group 5 is nitrogen. So let me go to that. Group 5. Nitrogen. What's the atomic number for nitrogen? Symbol N. Atomic number is 7. EC is 2 to 5. But what have we noticed? 6 electrons and each must contribute what? 3. So what we shall put 3 on the edge where sharing is going to take place. So I'm drawing the nucleus. These are the 2 electrons. Now out of the 5, what do? I'll put 3 here. The remaining 2, I can put them anywhere because I know each must contribute 3. So you bring the 3 ready to be contributed. So this atom also for nitrogen does the same. Therefore, this is EE. It also brings 3 E's here and keeps the remaining 2 away. So what do we obtain now? You are free to add the 2. You can add. It is allowed to put a plus sign. So what do we obtain now? This is, so do we draw intersection? Do we draw touching? Any intersection touching, you are free. Choose what is more good for you. It can be intersection, it can be touching. And therefore, in an energy level, nucleus, in an energy level, nucleus. 2 X's inside untouched. 5 X's outside. Out of the 5, 2 are away, but 3 are being volunteered. The 2 is inside, not involved. The 5 is, but 2 are not involved. The remaining 3 are involved. So the EC has changed from 2 to 5, and 2 to 5, 2 to 8, and 2 to 8. So how do we write nitrogen? The formula for nitrogen is N, 3 dashes N, which we write with a notification dashes as N2. So what does it mean? The 2 nitrogen atoms are held by a triple covalent bond as a result of having 6 electrons being shared, but each atom contributes 3. Here we end with nitrogen. This is what we look at. Now we can briefly look at quadruple for 4, but commonly single, double, triple maybe, rarely quadruple. So let us see, rarely a quadruple, and I'll open up room for discussion. So I'm about to come so that you ask for the next 8 electrons and each contributes 4. Atomic number for carbon is 6. Electronic configuration 2, 2, 2, followed by 4. Now each one is going to contribute how many electrons? 4. So what do? We put all the 4 electrons on this side. So these are the 4 electrons. 1, 2, 3, 4. Another carbon atom, all the E's here. I think you can guess what's going to happen. Can you predict? What are we going to form? So what's the E's? How many electrons shared? 1, 2, 3, 5, 4 of those ones carbon. A quadruple 4. Therefore, Vivian, you are quarreling for breakfast. I will allow you to go and take breakfast. Ayebaziwe, you have gone to the kitchen to disturb for breakfast. I'll allow you to remain there. So that's what it means. Single bond, 2 electrons shared. Each contributes 1 electron. Most likely among group 7 alone. Double bond, 4 electrons shared. Each contributes 2. Most likely among group 6 alone. Triple, 6 electrons shared. Each contributes 3. Group 5 alone. Then quadruple, 4 electrons are contributed by each atom, and therefore a total of 8 electrons are shared. All right, Asimwe Clarissa.
Teacher, I was asking on nitrogen, if electric configuration is 2 to 5 and there are 3 electrons which are being shared. So why do we write it as N2 instead of N3?
N2 means there are 2 atoms. If I say N3, it means that there are 3 atoms of nitrogen. So N3, this is the meaning of N2. N2 means nitrogen connected to nitrogen, but the 2 are connected by a triple covalent bond. When you say N3, it means I have 3 nitrogens. In the diagram, we have not seen any 3 nitrogen atoms. So they are not 3. So the number you see here is telling you the number of atoms that are involved in bonding, not the number of electrons. So why we write hydrogen as H2? Why not just H? Because there are 2 atoms, but these 2 atoms are being held by a single covalent bond. So H-H. Look at that one. You look at O-double-O. Now you look at N-triple-N. This one has 2 atoms, H and H. This one is written as H2. The 2 here means that the 2 atoms are similar and are involved. But each atom is held by a single covalent bond. Each atom contributes 1 electron. The meaning of O and O here means is O2. There are 2 oxygens, this oxygen and this oxygen. But these 2 oxygens are held by 2 covalent bonds. Each is contributing 2 kebabs. So this one means this is giving us N2, but each N is linked to the next N by having 3 covalent bonds. So if it's kebabs, here each student contributes 1 kebab. Is the meaning of this. This one means we have how many? So when you see 1 dash, it means 2 kebabs. Each one student contributes 1 kebab. Here it means each student has contributed 2 kebabs. That's why you have a total of 4. Double means 4 electrons. Triple means 3 electrons between the 2 atoms. So N does not represent the number of electrons being shared, but N represents the number of atoms that are involved. That's why in the school, sometimes somebody, you and a friend, you end up eating 8 sumbis. On another day with another, you end up eating 2. It doesn't mean the day you're going to eat 2 sumbis, you are going to be a half. You can still remain 2, but you're sharing only 2 sumbis. So the 2 stands for the number of atoms. In a formula, we don't show the bonds. Unless when the topic is bonding, that's when we expect you to show the bonds. Any other question? So Paul, unless you have something to say, you are unmuted. Hajara.
Teacher, I was asking, like, if these 2 atoms, like, they share electrons, I thought they change their name.
Well, they don't change the name. When they share electron, they don't change the name. A chlorine atom becomes a chlorine molecule. A hydrogen atom means 1, becomes a hydrogen molecule. What's a molecule? Combination of 2 or more atoms, which can be similar or can be different. How? Either by sharing or by transfer of electrons. So this is a molecule. Oxygen atom, oxygen atom, oxygen molecule. This is carbon atom can form a carbon molecule. So at this level, they remain with the name. Oxygen atom becomes oxygen molecule. Oxygen, oxygen, nitrogen. Now let's say, name the components of air. What are the components of air? Oxygen. You don't say anything else. It remains oxygen. The next one is nitrogen. The next one is carbon dioxide. So we are going to see carbon dioxide also, but in carbon dioxide, the atoms are not similar. You come in with different abilities. For you can contribute to 2 sumbis, for me I can contribute to 1. So there is a scenario where the atoms don't have the same contributing powers. And that is our next discussion, covalence in different what? Atoms, so that the topic is also complete. So that's what it means. So the names remain the way they are. But if it's more than 1 atom and the atoms are different, then the name changes, because hydrogen and oxygen are not the same. So when the two marry, they now become what? Water. Carbon and oxygen becomes carbon dioxide. Hydrogen and chlorine will become hydrogen chloride. Carbon and chlorine, carbon tetrachloride. There the names will change, but in simple atoms like this one, we maintain the original names. That was a good question. Alicia? Alicia, can you ask?
Teacher,
Yes, please.
I was asking, in covalent bonding, you only use 2 atoms.
It could, it is not a must, they must be 2. They can be 3, they can be 4, but the answer is 2 or more, not strictly 2. There are cases where you have 3. We shall see. Because in water now, you check in water, are they 2 atoms? In water there are more than 2. There are 3, 2 hydrogens and 1 oxygen. So there the scenario is different. So in similar atoms, we use only 2. In different atoms, they can be 2, they can be 3, they can be 4, they can be 5. We shall see. So how many senior ones will a senior 4 want to be around her? A senior 4 will want 4 senior ones to be around her because each senior one is 1, but a senior 4 needs 4 friends. So you have to bring the senior ones, you have to bring 4 of them to bond with her. A senior 3 with the senior 1 senior 3 with 3 senior ones. A senior 2 and a senior 1 senior 2 versus 2 senior ones. You get it? So that's the scenario. So if a senior 1 wants to bond, if a senior 1 wants to have a relationship with a senior 5, he must collect how many? 5 senior ones to come with them because a senior 5 needs 5 of them, and since each one is contributing 1, 1, 1. Senior 6 is supposed to eat 6 chapatis. The canteen rule says a senior 1 can only buy 1 what? Chapati. So if I'm to send a senior 1 to buy chapati and a senior 6, how many senior 1 should I send? I send 6 of them because each one can buy only what? 1. That's different now. Supposing I'm a senior 6 and I want 6 chapatis and I'm sending a senior 2. How many senior 2s will I send? It's mathematics ratios now. My question is, I am a senior 6. I want 6 chapatis and I'm sending a senior 2 student. And the rule says a senior 2 can buy only and only how many? 2 chapatis. So how many senior 2s do I send? I send 3. So you can see the atoms are changing. Myself plus 2 senior 3s who are 3, we are now 4 in the system. That's what it means. All right, Elizabeth. Elizabeth.
I was asking.
Before you ask, Leila Hanifa, you're again unmuted. We are listening to radios. Leila Hanifa, there is another person, another class. I am removing you. So. Let me remove her. So you ask.
I was asking, after doing the hydrogen atom, like below it, are we supposed to write hydrogen plus hydrogen gives you hydrogen dash hydrogen? Are we supposed to do that?
Yeah, you can illustrate. It's okay. This illustration is okay. There is no problem. It depends on what the question is saying. If the question is saying draw only, if the question is saying explain. In an explanation, you try to put as much content as possible to be as clear as possible. All right. Nantava.
I was asking, back in ionic bonding, is it possible to have 2 different receiving elements?
It is possible. That is very possible. But at your level, we look at the more than 2 receiving must be similar. But there are scenarios where the 2 that are receiving can be what? Different. we bring in what we call complex molecules. We don't study ionic compound and complex molecules at senior 2, but it's possible. I can give a senior 1, donate to a senior 1, at the same time donate to a senior 2. Those are two different people. And therefore, the compound I form is going to be different than when I donate my electrons to a senior 2 or a senior 3. So that one is possible, but under complex molecules, which we shall look at in our next discussion. Who is left now? I think I've responded to your questions. Those in the studio you have not asked. Elizabeth, your hand is still up. Elizabeth, your hand is still up. Is there something else you're asking? Eh? Nothing. There are people, there are guys who are attending our lessons, but they have not even asked a single question. Let me look for them. Not even a single question. There is this Svensson. What are you asking? Okay, you can keep quiet. A question from Sven. Yeah, big coward. It is okay. In the studio, any question you're asking? So, if nothing, then I'll briefly, oh, there is Hassan. Husna, sorry. Sorry to call you Hassan. Husna asked, hey, Husna, you just put up the hand for a show. Okay. Atim.
Teacher, my question is, okay, it's not a question, but I can't see the last part of the board. The last example that you gave, you wrote nitrogen, then the 3 dashes, and then you put in brackets, and I can't see that last part.
I was just illustrating that H bonded to H, we write it as O2. Hydrogen, hydrogen single bond, oxygen. There is also oxygen double bond, oxygen, we write it as O2. We don't show the bonds when we are writing the molecule. Likewise, I say nitrogen, triple bond, nitrogen, we write it as N2. It was a response to one of you who had asked, why don't we write nitrogen as N3 since it has a triple bond? I was saying it cannot be N3. N3 means there are 3 atoms involved in the bonding. Yet in actual sense, there are only 2, but both of them are being joined by a covalent bond. That is where the illustration was coming from. And I shall lastly receive a question from Ado Theodora Melanie.
Is it true that in covalent bonding molecules are formed and in electrical bonding ions are formed?
Mwanza Mozanyela, you have answered yourself. In ionic bonding, we form ions of opposite charge. In covalent, form molecules that don't have charges completely. So they are neutral. They never form ions at all. Ionic ions of opposite charge. It could be also a molecule. For example, sodium and chlorine, we form a sodium ion held by a chloride ion. And therefore, the molecule is sodium chloride. But the biggest issue is this sodium chloride has ions in it. While, for example, chlorine and chlorine, we form a chlorine molecule. This is a molecule. This is a molecule. This molecule of sodium chloride has ions. This molecule of chlorine doesn't have ions. So not all molecules have ions, but all ionic compounds are molecules. Right. So with that, maybe I'll pick the last question, and the last question is coming from Benita. Benita, the last question is coming from Benita.
Teacher, do covalent compounds conduct electricity?
Now you have hurried to crawl, you have hurried to eat cassava before they wean you from breast milk. You are running before you crawl. That will be the last thing having looked at covalence in different molecules. But for your own information, not sure the teacher did not know the answer. Covalent compounds do not conduct what? Electricity. They never conduct electricity. Why? They don't have ions. And we shall see that. So briefly, just very, very, very briefly, let me introduce only one aspect and we close. Atim, you asked, your hand is still up. Atim, your hand is still up. Benita, can you mute your microphone? You might miss the summary. Very good. So let me introduce one aspect, covalence in different atoms. Just a simple one only. And it will be a curtain raiser in our next discussion. This will be now between, for example, hydrogen and chlorine. So hydrogen and chlorine. Electronic configuration for hydrogen, 1. Electronic configuration for chlorine, 2 to 8 to 7. Do you see the same scenario? So what happens? This is hydrogen. Now this is chlorine. As my last statement. So this is X, 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 of course 7 outside. And these are 8. So you have seen, I need 1, you also need 1. So what will be the result? The result is hydrogen connected to chlorine. So if hydrogen is connected to chlorine, hydrogen connected to chlorine, if hydrogen is connected to chlorine, for hydrogen is the nucleus, that is its electron. Chlorine has 3 energy levels, just a curtain raiser. This is XX, these are 8, and we shall begin from there. So where are the 7 electrons? I have these 2 X's, we have these 2, I have these 2, and I now have that. So how many electrons are being shared here? 2. It is contributing 1, but the atoms are not similar. Hydrogen and chlorine are different. So this is hydrogen, this is chlorine. So what have we obtained?
My sleep is fading.
Pardon? So Vivian, you are missing. So this is H. Single bond. H, single bond. 2 electrons are being shared here, but it contributing 1. Hydrogen. This type is not hydrogen, chlorine, hydrogen, chloride. And the same as chlorine. But this is between senior 2 West student and a senior 1 West student and maybe a senior 1 North. The other time was West alone, East alone, South alone. Now it is interclass between West and. So the atoms are different. Single covalent bond. So we shall continue with our lesson from that point. On your WhatsApp group, notes were given. If you did, I can still say, read through the notes on covalence so that next time we meet, we can easily conclude. And upon concluding, then we look at something else. So I want to end the lesson, but my request and my caution to senior 2 students is you are misbehaving with your microphones. Please try as much as possible to mute. Thank you so much. Assalamu alaikum wa rahmatullahi wa barakatuh. The same Shifa who has been disturbing.